This is Dr. Whitman. I'm back for a look at the contours, or the way we tell hillsides from flat ground, on a topographic map. To refresh your memory, we're in the state of Indiana. We're looking at what's called the Nashville Quadrangle Map, which is in Brown County of south central Indiana, as shown in the little diagram at the bottom of the map. Now, today, this broadcast concentrates on how we tell hills from valleys and ridges from stream beds, and how we can tell which direction a stream is flowing, and how we can tell how steep or not steep a hill is. So let's get into it now. As you look across the map, what you see is some areas have a lot of brown in them. Those are hillsides. This stream valley here is actually a very flat area, and the way we can tell is there's a whole lot of distance between one of these thin little brown lines and the next thin little brown line. And that's called relief. And before I go any further, I first check the scale of the map. This is 1 to 24,000. 1 inch on the map, paper map, represents 24,000 inches on the ground, or 1 foot on the map represents 24,000 feet on the ground. The most important thing we need for contour reading is what is the contour interval. That is the measured level above sea level, and what increment is used to define this upward movement in hills. For example, in this map it shows the contour interval is 10 feet. So let's go find a hill to examine. Now, to begin with, we're going to look at these index lines. That is to say, every fifth line on this map is a slightly heavier brown color than the ones before it or after it. And since we know our contour interval in this case is 800, and we know that they use feet on this map, we know that if we have a spot on this line and we want to know how far above sea level it is, well, we happen to know that it's above 800 feet, because this circle that 800 is on goes all the way around this area, as you see. So this next line up represents 810 feet. This next one would be 820 feet. This would be 830 feet. Then you'd have 840 feet. Now, because hilltops are very rarely flat, on the safe side, we often estimate that the hilltop, if it doesn't have an X with an actual reading on it, we give it 5 more than the next lower contour line. So in this case, it's above 800, so it's 810 feet here, 820 feet above sea level here, 830 feet, 840 feet, and we would call this 845 feet above sea level. Now, some other things to show you. When the lines are far apart, as they are here, this is a very gentle slope. However, if we try and run down this side of the hill, we're going to run pretty fast, because when you see contour lines that are very close together, it means it's steep ground. And here we have something you don't find very often, and that is 800 feet, 810 feet, 830 feet, and then you have a circle, and it's blurred a little bit here, but what you really have is sticks pointing in, so that this is really, this circle here that the cursor is on represents 10 feet lower than the previous contour, which implies that this is some kind of a quarry or depression. Those inward lines refer to a depression. Let's see if we can find a marked hilltop, one that's been surveyed. And here we have one. This X shows that this hill at that point is 788 feet above sea level. That's a really odd number, because almost everything on this map will be in tens. 700 here, And again, every fifth line is a darker line. 710, 720, 730, 740, 750, and this one is darker. So I'd expect the hundreds and the 50s to be marked in a darker color. And if you follow this heavier brown line around, you'll see that it comes over here to this 750. So the marking is consistent. Because there's no green on this map, we infer that when the time this map was made, this was mostly forest that had been harvested. This looks like the eastern side of a slope because it's on the right hand side of the map of this hill, and this would have been lower ground here, and it looks like it's been harvested here and over here where this bare stuff is, but it's been so long that this may no longer be clear area. Now there's some other marks here for water. When you see this blue implies water, and this implies higher ground on either side, almost like river banks. Over here where you see a blue line but you see dots in between, that implies that it's a stream that only flows during times of when there are rains washing down off the hills, and that makes sense. Let's see if we can figure out which way this stream, this intermittent stream, when it flows, which way it's flowing. And it's actually easy to tell. These little contour lines here that have this hook in them actually point uphill. So we know that this water, when it flows this way and then joins this stream this way. Now, this other stream, let's see if we can figure out which way it flows. Looking for more contour lines and I'm not seeing very many. It implies that it flows in this direction, northerly direction. This BM benchmark is a surveyed point as well. It's like that X I just showed you a few minutes ago. And this one is a surveyed point with a permanent marker in the ground, a brass marker. This one says that at that spot it's 618 feet above sea level. The purple, if you've forgotten, implies a change. It's probably a housing development or something like it that has happened since the original map was surveyed, and this particular road here is a road newer than the older one when the map was made. And this, because it's a solid color and it's thick, implies that it's a interstate highway or a large state limited access highway. Let's go on to some other things. Let's look at another stream here. What you've got is an intermittent road, or probably a logging road or unimproved road here. But what you see here is contour lines that are hooked here and here and here and here, implying that this stream flows in this direction, which is most likely the case. Next, you should see that there's sometimes some unique features to the ground. For example, this ground is slightly above 800 feet out where the cursor is, but in this direction, going south, it gradually goes down. Then there's another little tiny hilltop, and then it goes down again and again, and it keeps extending out in a very gradual way in this direction. This is called a ridge when you see a series of gradual declines in a hill. There's some other features to show you. Steep ground, this would be steeper ground over on the left side here as opposed to this ground over here where it's more gradual. Occasionally you'll get a feature called a saddle, which is where you have a double hilltop that's real close together. Let's see if I can find you one. This hilltop here and this hilltop here, and in fact this third one here, constitute a saddle, which is to say that there's a high spot, then a low spot, and then another high spot. In fact, there's a double here, which is a little unusual but interesting. Here's another one here. Here's high top, high ground, lower ground, and then higher ground again, surrounded at the same level. So So that is what we call a saddle. A few other things, a reminder. Let's go up to the very top and I'll show you, starting at the east top northeast side of the map, that this particular map is 39 degrees, 15 minutes, and 00 seconds implied with the two marks like you see here. This is the farthest north that this map goes. So if you had a reading that was 39 degrees, 16 minutes, it's off the map. If you have a reading that's 40 degrees north, it's off the map. Because these are in Indiana, when we write these out, we would always place the letter N after longitude, and we would always place the letter W after our longitude, because our longitude is west of England. And as before, as you go across a topographic map, it's called a quad map, there are lots of numbers along the edge of the map, and the ones that we're interested in at this point is the ones that are marked with degrees, minutes, or seconds. We only find degree markings at the corners of the map. Inside the map, this would be the same longitude, degrees that is, 86, and it's 10 minutes and 00 seconds. And what they're telling you is that that point is 2 minutes and 30 seconds, or 2 minutes and a half, greater west, further west than this point in the corner here. And if I go along further, you saw 10, and again 00 is implied. If I go along further, I'll see 12:30. As you see here, still 86 degrees, 12 minutes and 30 seconds. And if I add 2 degrees 30 seconds, which is the same as 2.5 more to 12.5, I would come up with another whole degree of, minute of 15 minutes. So it's still 86 degrees on the corner of the map here, and now it's up to 15 minutes. And it pretty much works the other way too. Now, you don't always have 15 minutes at the corner, but in this map you do. As before, blue indicates water. Well, that's all I have for now. I hope you've enjoyed this.